So it's a pleasure to have you here again with us for the second time. You have been in the online one. Yes, sorry, I tried to. Yes, you have been in the online one. It was the best attended sort of event, but it came with challenges. So it's a pleasure that we have you for the first time in person here. We've been knowing each other for a number of years, like 5, I think, since a conference on games in London, right nearby. Back in the days, you were still with Creative Assembly, still, so there must be something cool going on there. Duygu has been working a lot with strategy games, real-time strategy games, has been developing AI within Creative Assembly for a number of years. Loads of experience in that sort of particular game genre. So we're looking forward to hearing what you have to say. The stage is yours. Thanks. Thanks for coming.
It's really great to be here. Thank you very much for the invitation as well. I've been here since yesterday and meeting with great people. Also had a bit of chance to catch up with Dominic as well, who is working on one of our projects. So he's doing his PhDs and we're collaborating with him. So, you know, I love putting people on the spot. If you're interested, then you can find him in the audience and ask all sorts of questions. Anyway, so let's start. So as it's been told that I worked on AI for a number of years, and now in the last year or so, I'm building an R&D team. And yeah, there are like exciting things cooking there, but unfortunately, I am not yet clear to talk about those. But instead, I will talk about decision making in Super Mario Bros. Yeah. In yeah, turn-based strategy games. Right, I'll start with a little bit of the challenges of this genre, because no matter what sort of methodologies you use, challenges remains the same, and we sort of need to overcome them to be able to make good AI for decision making. And then I will talk a little bit about how we tackle them in a very high level. Yeah, these solutions are going to be mostly industry standard solutions rather than the more modern approaches, but I hope you will find them interesting, and I hope it will spark some interest around the space, and maybe new ideas will come on how to how to tackle these challenges. I'll distribute the slides afterwards, so I checked my contact details there if you want to contact me for whatever reason. I'm really bad at responding early, but I do it at one point, so apologies in advance. Just a little bit about the company, as traditionally. So we are around for a while now. It's been 36 years, actually. This slide is from last year. And we have around 850 people. We have studios in the UK, and we have studios in Bulgaria as well. Maybe you know us from Total War series. We have a franchise that we've been developing, like war grand strategy games for a while. And there's some other games we make as well, like Alien Isolation. Right, this is sort of the schedule for today. I tried to do 2 parts, and afterwards I'll talk a little bit random about thoughts and ideas about what is next. I'm saying that, but I think I'm lying a bit. I think I don't have that much time, so maybe I'm not going to talk about the diplomacy AI part, but we'll see how it goes with the time. Because I decided to add some stuff last minute, last night, as you always do. So I'm not sure about the timing. Anyways, we are talking about the AI that plays, right? So yesterday in the morning, actually, some of those challenges has been already discussed. Julian had a great discussion about this good old topic regarding game AI, playing to win or to entertain. So I won't go into the details, but I'll just say a few words in the context of strategy games. So yeah, in turn-based strategy games, the goal of the AI isn't to win the game. The main goal is mostly to create a sense of challenge for the player, and hopefully doing that in a believable way rather than defeating them. So essentially what we are trying to create is an agent that loses convincingly. The second important point here is, again, being mentioned, how to quantify fun. Because if we talk about winning, it's a much clearer goal, right? We can plan to win, we can learn to win, and so on. But when it comes to fun, it is a subjective term that changes from person to person. So it's really not that easy to quantify. Therefore, in turn-based strategy games, one of the challenges is to need to create an AI for a rather subjective goal. This makes it very difficult to use some of the well-known or well-researched techniques, especially if they are the ones who are focusing in finding good winning strategies. Right, the second challenge is about how to create variety in decision-making. Because in turn-based strategy games, there are usually several opponents, like tens or hundreds maybe. And in order to create a more organic and more, interesting experience, then we would like each AI opponent to have unique traits. Otherwise, the game would become very monotonous very quickly. I'm just holding this, but using my mouses and the practice. Yeah. So the next challenge is around partial information. In turn-based strategy games, the game world is usually not fully observable, neither to the player or to the AI. Therefore, when the AI makes its decisions, it somehow needs to be able to deal with this partial information. It can either have some systems in place to deal with, I don't know, for example, it can maybe predict what is happening under the hood in the shadows over there. Or it can have some mechanisms to invalidate its subsequent decisions when a new information comes to place quickly. And it has some other systems that actually manages to replan or remake its decisions. Right, so yeah, players typically own multiple of entities in these sort of games, and they need to make decisions on those. And also, there are usually various different gameplay systems that interact with those entities. I don't know, for example, skills trees for armies or building management system for territories might be some examples. And in each turn, the player has to do a big series of decisions in order to, play the game. And it's a combination of these entities and various game play systems are affected as a result. And similar to the player, the AI has to go through the same decisions for each of these entities or systems. What this means for AI is that it has a very large action space to deal with, which implies that the number of possible states that the game can be in at any time will be very high. So we need to come up with the appropriate decision-making algorithms to deal with such a large space. And our final concern is the execution time. So of course, we have way more concerns and challenges than this, but the final one that we're going to look into today is the execution time. So yeah, in turn-based strategies, players usually have tens or sometimes hundreds, for example, in total war games, opponents. So when they play their turn, they have to wait for all these AI opponents to make all these decisions as well. So we need to try to keep the turn times as minimum as possible, because otherwise you're breaking the immersion, you're sort of boring the player to death. Probably not that severe, but yeah. Well, even though turn-based strategy games actually have a little bit more better time constraint compared to real-time strategy games, but still with the really big action space and really a lot of opponents there, it is still quite a big challenge that we lose or sleep over during the development times. So, right, there's a find a connecting sentence note here. Here's my connecting sentence that we are done with the challenges. Right, next, let's talk about a little bit of TOTOVO and see how these challenges manifest themselves in the game. For those who don't know, TOTOVO is a grand strategy game series and it has two parts. The first part on the screen is grand scale battles and they are real time. And the second one is turn-based campaign, which can be classified as an empire building game. In the game, there's a large map and territories. And as a player, you play as a faction and you control some armies, you have some territories, and you have some enemies. And your goal in the game is essentially world domination, either through bloodshed or diplomacy. In this section, we will only be focusing on the turn-based parts of TOTOVO, and they're actually implemented as separate games anyways, because their challenges and everything is quite different than each other. Right, so how do these challenges manifest themselves? So in TOTOVO, actually only players have win conditions. The AI cannot really win the game, cannot physically win the game. Well, there's one exception, but apart from that exception, they cannot really win the game. So the AI's goal in the game, it means, is different than the player's goal. It is instead of winning, to play the game, interestingly and give a sense of challenge to the player. As a side note, this actually sort of makes it difficult to use techniques such as modeling plays, for example, from data, or imitation learning sort of things for decision-making domain, because we actually want to create an AI that is different than what players are doing in the game. But yeah, this makes it difficult to use strategies to win the game. But yeah, let's take a step back and see how we would approach if we would like to use some AI techniques that focuses on how to win the game. So perhaps we need to think about then how to translate or mimic some of the win conditions that would drive the AI where we want to be in this case. One approach here is to approximate some of those winning conditions. For example, we actually use these sort of things a little bit as well. In one of our AI subsystems, we compare the AI's military strength to the others in question. And then we say if the AI has a clear predominance in strength, then they win the situation. Otherwise, they lose the situation. So even though this approach helps us to find a smart strategy to win the situation in this particular situation, and it works in a smaller subsystem in a smaller scale, it doesn't really solve the problem of ultimate goal of AI creating fun or challenging solutions rather than winning. Not having win conditions also creates a bit of a problem, because AI doesn't really have any clear goals to play the game towards. So the show must go on for AI until the player wins, or the player does so badly that it loses. So yeah, how do we look into this then? So instead of having an end goal for the whole game, we've actually created some sort of direction for all the systems. We've created some sort of data-driven policies to drive the AI instead. This is basically a combination of sub-policies for different systems, and they advise each system on what direction to follow. For example, what they do with their budgets management, what they do with recruitment, what they do with military behavior, and so on. I've spoken this much for a while, sorry. Right, the second thing we've talked about is the variety. In Total War, the desire is to create many different factions with many different characteristics and playstyles. And these are usually inspired by history for historical titles, historical characters, for example, or lore for our fantasy titles. That means that the AI decisions should be able to reflect these different characteristics or these different play styles to create variety for us. And for this, we created different personalities for each faction. These personalities are at the moment a combination of those policies that I mentioned before. Those policies also define what sort of parameters to go into each of those decision-making systems so that the decision-making systems make different decisions based on the personalities. Yeah, just to give you an example, for example, we can have a brave warrior personality who will have a tendency to spend more money on military buildings because of its budgeting policy, because it prioritizes military expenses. Or, for example, for a kind diplomat, they can actually spend more money on making deals so that they're making friends and they're making diplomatic dominance over the map instead of spending money on military. And they try by all costs not to get into any war unless it's absolutely necessary. So yeah, I think one of the things, this is sort of off script, but one of the interesting things would be to look into those personalities and actually whether we can learn it from players, for example, or whether we can somehow generate those personalities with interesting approaches. That still needs to be following law or history, but yeah, I think it would be interesting. Anyway, partial information. Total War experiences fog of war, and similar to the players, the AI cannot see some of the parts of the map. This means that, yeah, the outcome of an AI action may reveal some new information and change the worldview. Therefore, it might make our current decisions a little bit moot. So to deal with this in Total War, we don't actually really count on a longer term plan. The systems are way more reactive and myopic. Well, a little bit more than what we would like actually, but it really helps with the partial information. They also invalidate consequence decisions given a state change as well, the AI system, so that really helps as well. And just a side note here, this is not the only reason why we don't have longer plans in Total War. The main reason, actually, I would say, is that it is extremely difficult to evaluate any sort of reward for an action in Total War for longer strategy. Because you make a lot of decisions in one turn, and it changes the world state massively. And the effects of those actions are so tangled to each other that it is very tricky to analyze the contribution of an action to a longer term strategy. So that's why we have a little bit more reactive and short term plans. Just to give you a little bit of idea about the action space, in Mortal Empires campaign, which is one of our largest campaigns, we have 278 factions, and each of those starting factions, they go smaller as we progress in the game. And all those factions can hold a lot of armies, and all those armies have different actions to do, maybe like 10, 15 actions and so on. And yeah, there's a lot of regions they can go and recruit as well. And army domain is just one domain, right? There's like a lot of different things you can do in the game, building, 50 buildings and so on. So thinking about all the combinations, I mean, I sort of tried to calculate, but then I gave up. But you can easily see the, combinatorial explosion of number of actions here. Right, so the action space in Total War is a beast to deal with. Well, our approach to dealing with this massive search space is dividing that into smaller domains and solving smaller problems in smaller domains separately. For each of those domains, we are also using, different techniques, different approaches with different, sub-AI systems, so that we create, hopefully, the most fun and challenging solutions. I might be talking about this a little bit more later. Right, as I said, we are trying to keep the turn times as small as possible in campaigns, and I put some numbers on that Warhammer 3 in Portal Empires. So these are average numbers for average stats machine, average spec machine. And very roughly, we can also say 50% of those total turn times is AI and 50% is something else, like rendering, for example, or gameplay systems working behind the hood, behind the curtains. So if you calculate roughly, actually each AI has around 100 milliseconds to make its decisions, which is quite a restraining thing, I would say. So even though this may also sound counterintuitive, when you look at the numbers, probably as we go along, some of those factions will die, and you would expect the numbers would get better, probably, right? However, as we progress in the game, you start to have more skills, you start to have more things to build, you have more shiny toys in terms of gameplay systems. So it actually gets more and more challenging to keep acceptable turn times as you go along, and it's getting more and more challenges to make good decisions as well. So to tackle this challenge, we have done many dark tricks, as Julian called them yesterday. We prefer to call them optimizations. Yeah, we have done a lot of structural and procedural optimizations. We optimize day and night. And what I mean by structural optimizations are things like, for example, using the power of caching, or usage of custom allocators, sort of stuff. And for the procedural optimizations, it is the domain-specific information to reduce the search space, or, for example, parting approximations to use in the decision-making rather than using expensive path-finding algorithms. Right, the first two are usually the challenges around design challenges, and the last three are more of a technological and more of a engineering challenges, I would say. And connecting sentences is, now that we have discussed the challenges for building AI in turn-based strategy games, and how they manifested and sold in Total War in a very broad sense, let's go into part 2 and see a little bit on how we implement decision-making in Total War. So we said we have a lot of different gameplay systems. So all those gameplay systems are the things player needs to make their decisions, and the AI needs to make their decisions. Therefore, they're actually our decision domains. And as also we covered earlier, we have a massive search space, so we're dividing it and creating different decision systems. I mean, in some of them, for example, we use search-based solutions. In some other, we have implemented some very highly data-driven systems that the designers can control the systems very easily, and then we do testing, automated testing day and night, and then we do some statistical data analysis on that data and feed it back to designers, and designers play with the data and those sort of things as well. I'm not going to talk about all of those systems, but I'm going to talk about, oh, I have one more slide before going into the task management system. Yeah, so by implementing individual siloed systems, we actually made a little bit of a trade-off, because we managed to make the decision spaces smaller, and we managed to improve our turn times really good. But on the other hand, we fell a little bit short on the coordination when it comes to what all those decision-making domains are doing. We came up with different approaches to mitigate this problem. For example, we gave a little bit of restricted introspection capabilities to each of those, so that they can look a little bit on what each others are doing and adjust themselves. We also introduced like contextual awareness in each system, so that they can understand in the big picture what's happening. But I think the mitigation that we've done that's impacted or that helped us the most is giving a indirect control to financial system over all the other systems. So this indirect control comes from its responsibility of determining how much budget each of those systems will get. So this top-level coordination between the systems at least sort of helped us ensure that they're all steered towards the same sort of direction, which is not perfect, but that's what the trade-offs are for. So, right, we have the different systems. We have different approaches and techniques in all those subsystems. But one thing in common between those systems is all of them introspect the world state, of course, and make their decisions based on various different bits of it. And as I mentioned before, we've done a lot of structural and procedural optimizations, and how we implemented the world state is an example to both of them. So, yeah, we don't like doing anything big, right? I mean, probably we agreed until now. So instead of having a big world state analyzer, we created a number of smaller and more focused analyzers, which processes the parts of the world state and turn them into analysis. Some of them are on the screen. So those analyzes the world state, and they keep it in a central place, so that when the decision-making systems need to ask about the different pieces, then they can go to a central place, so that it's not evaluated over and over.
These are feature detectors, essentially?
Maybe.
What do they output a number?
No, they output a different type of analysis. For example, strength analyzer might output a strength number for each of those factions, or the one that analyzes the spatial information might actually output a number of factions that is neighboring for you, or it can actually output some indicators about how the relationship between each of those factions are, so that, for example, the diplomacy system can decide what sort of deals to give to each other. Yes. Yeah, also very quickly, because analyzing stuff is computationally very, very expensive. We only update the analyses only when we need it, and only when it is out of date. For that, we build a dependency graph with the objects and the analysis themselves. So whenever something changes in the world, it can actually create a chain of invalidation reaction going from bottom to top, invalidating other analyzers. For example, here, if something has changed and or mobile military strength analysis is invalidated, then it will also tell the faction and the alliance ones that they are invalid now. But then, whenever a decision system reaches to that system, that orange one, we recalculate it and then we compare it with the previous one. So if they are the same, we are saying, oh, okay, we actually didn't need to update anything. So we go and tell them, oops, we made a mistake. Can you clear your invalidation bit, please? Because you don't really need to update. Right, so we talked about smaller system, different decision-making techniques we are using, and we discussed a bit of pros and cons of these, and we looked into how world state analysis play a role in that. Now let's go into the details of one system, actually, the bloodshed one, and we can see the approaches and how we dealt with it. Again, let's talk about the game mechanics a little bit. As mentioned before, a faction has different things on the map. It has armies, for example, navies or agents. These mobile, resource mobiles, we call them because they are a resource to the faction and they can move, so they are resource mobiles. Can do different actions, moving from one region to another, raiding a region, attacking a faction, recruiting units, and some more. So the problem in this domain that we're trying to solve is trying to find a good combination of actions for the faction, sourcing these with the most appropriate resource mobiles, and then making a plan out of those actions with the best order and with the possible coordination or cooperation of these resource mobiles. And we do it in 3 steps. First, we generate possible tasks that are relevant to the faction. Then we allocate resources to those tasks. And then we look into how we can execute those tasks with the allocated resources effectively. These are the tasks I mentioned, some examples of them. And yeah, the task generation system is responsible for building a generic list of all the available tasks and for the faction. And it actually assigns some priorities to those as well. And those priorities comes from personalities and with some adjustments of with some adjustments according to the world state. And then this system sorts them. Also, the other thing this system does is creating some requirements for those tasks. For example, if you are attacking a navy and if that navy is in the middle of the sea, then obviously we need another navy to be able to attack them. Or, if you're defending a region and if we see 3 big armies coming towards us, it doesn't really make sense to send a small army there. We calculate the potential strength of the enemy with a bit of speculation, and then we put that as a requirement to a task. So yeah, then that requirements actually informs the next step, which is the resource allocation. So now we have tasks along with the requirements, and we also have a list of resource mobiles that are available for our faction. The next problem here is how we assign these resource mobiles to the generated tasks by satisfying the requirements. So there's, sorry. So to solve this, we have used MCTS. Maybe you have heard about it. So in our case, we use each node here to represent an action of resource fulfilling. Then we build the search tree through allocating resources to tasks in each different node. And we end the playout when there's no longer a task to allocate or there is no longer resource. And then scoring is based on the current resource allocation and tasks. So the scoring function looks at how good the allocation is, how many tasks we manage to allocate and how good they are, versus how many we fail to allocate versus how good they are. So here we are actually not using MCTS to play the game because we don't actually have a forward model. But we use the MCTS to solve our resource allocation to tasks problem. Yeah, we are actually not running a simulation of the world forward, but we are running a simulation of the allocation itself. And it works quite well, I would say.
So it's simulation at like a higher abstraction level because
yeah.
Right. So you say that if you do the thing, the attack this, then this would happen. It's a symbolic overlay.
Yeah, yeah. Right, now, from the previous system, we know which tasks to execute and with which resources. Now it's the resource coordination's turn to shine to find the best execution order to for these tasks with resources. Along with some spatial decisions as well, right? Because it needs to find the safest path possible to be able to attack somewhere. Or if two armies, for example, crossing paths, maybe we can find some collaboration opportunities there. This system utilizes some gameplay and AI systems such as threat analysis, for example, or pathfinders, influence maps, so on, along with another take on MCTS. So here we have two types of nodes, target nodes, action nodes, and we build the tree by alternating them. And we did the usual steps of MCTS. I'm not going to go there, but one thing to note here, as I mentioned, we don't have a forward model. But what we've done is creating a limited world model and a simulation on that. So the coordination itself has a very simplified world model. And what we try to do is to figure out what happened there, but with doing a lot of estimations to figure out how the world would look like. Yeah, and scoring, this is basically, as I said, it's an estimation of a upper bound on how many units we would lose versus the estimation of a lower bound of how many units the opponent would lose. And yeah, it's important probably here to say that even though the system plans the whole turn for the faction when it starts executing them, if we actually end up figuring out some new information from the fog of war or anything else, because it's MCTS, we can easily invalidate the rest of the plan and replan. We have also used some black magic here to optimize things. We use domain-specific information, of course, to direct us to build the tree in a smarter way, but I won't go into details of those things. So a little bit of takeaways. Essentially, we figure out what decisions to make in the army domain. And we create a system that generates tasks based on personalities. That lets us to create a dynamic and variety full system. So that's why this is a step towards the challenges of 1 and 2. Our coordinator has the ability to evaluate the world state and invalidate a plan. So that's how we are dealing with partial information in this stage. And finally, we made a lot of black magic in each step to reduce the action space and decrease the AI execution time. I have 15 minutes. I don't think I will talk about diplomacy. While I'm skipping through the slides, if there's any questions, I'm happy to answer.
You mentioned it was a very, the space changed a lot over time. Is it appropriate at all to do any work in advance? Like the player's turn, there's not much AI going on during the player's turn. Can you do any of your AI there? And what have you had?
Yeah, we've tried that a little bit. But the problem there, and I think we can do this better, I'm not saying, you know, it's a dead end. But in the limited space we've tried, essentially what happens is the world state changes a lot because there's like 200 other factions, right? So you make some decisions ahead of time, for example, for your faction, but by the time it's your turn, the world state is completely different. A lot of analyses are invalidated. A lot of decisions are invalidated. So we couldn't really manage the game too much time. But yeah, I think maybe some sort of layering this in a little bit different way and maybe figuring out what doesn't change much and doing the high level sort of planning ahead of time might be something that can work. Yeah.
Those are quite a long running series now. Could you tell something about like the major milestones in the development of these AI systems throughout the history of I don't know how long
Oh God, that's the difficult question. I've been in for 8 years, so I haven't worked it for a long time, and I think I need to think a little bit about that to get my thoughts. Let me think about it, and maybe we can discuss about it a little bit in the break. Maybe one more question, and then I can continue, and then we can go on with the questions.
really interesting work. Although I didn't really understand how the NCPS was working exactly, I noticed that every child was a different level, in terms of resource allocation. Could you maybe like give us an example of how you're able to simulate the value of any branch or any child? Figure out forward model.
Yes. I mean, I said we don't have a forward model, but it is because we don't have a forward model in the game, but we are actually not solving the, you know, playing the game with MCTS. So we still have a simulation. We are still running some sort of simulation, but it is the simulation of the allocation. So in each step, for example, when we do the rollout, we look into, you know, we expand the task and we allocate it, and then we expand another task and we allocate it. And while we're doing that, when we look at the scores, we are looking at, okay, in this branch now, how many tasks are resourced and what's the score of it. And, you know, there's a bit of a formula there that I didn't put on the slides, but it also looks at how important those ones, because we have priorities from previously. And then it compares it with the failed allocations and comes up with a score saying like, oh, okay, actually this branch looks good now, or maybe not that much, so that, you know, we do the rest of it within that space. So the search space is actually set of possible allocations, and yeah, we are actually looking at the options of assigning resources to various tasks. Was it?
Yeah, more or less actually, I understand. But so the score that you mentioned, that is based on the priority that you already calculated. Like, how would you say that this allocation is better than this allocation?
Yeah, so priorities and whether the requirements are satisfied or not is essentially the core of the score. Yeah, you're absolutely right. No worries. Right, I'll just talk a tiny bit about the feature now and wrap up. Still have 10 minutes, right? Yeah. So in this session so far, we've talked about how we can implement decision-making in turn-based strategy games and with more traditional techniques, right? So the question now is, what is next? How we can actually improve the decision-making for this genre? Is everything okay? Am I? Okay. So there may be many different directions to take actually here, but I have a little bit of time, so I'll just run through a few thoughts here, and maybe it might be a good start of a discussion. So like rest of the studios, we are also interested with different modern approaches, right? Generative ways of doing things or learning in different ways. And we want them to get into our day-to-day working environments. We are actually very interested in the scope of the decision making. Can we get AI to learn how to play Total War to achieve the next level of fun for our players? With that in mind, you know, it actually needs to solve the challenges that we've talked, but it introduces a few more challenges as well that we have already solved with our current systems that we need to think about. For example, one of them is the mess of game development. It's a huge team effort and it takes multiple years, right? In Total War Three Kingdoms, for example, which is a smaller project than the Warhammer 3, we had like around 80 core developers, just programmers, designers, and a bit of core artists. But then when you think about the rest of the team, like localization, QA, audio, all those support teams, it becomes 200, 250 people really easily. And again, a lot of years. So majority of this time also everything is in a flux. So you start developing the game, maybe the first year you don't really have a stable game to run there, stable game to do some tests or run simulations or things like that. And then when there's a stable game to play, then again every day all those 200 people commit new things, right? So essentially every other day your game is a different game than the day before. By the time the game gets like very consistent, by the time the game is there and you can actually play and it's not a different game anymore, then you reach the alpha, then you reach the features block and you can't actually change the game much because you tested it so much, you're very happy with it or slightly happy with its quality. So it's super risky to add new things or super risky to change the balancing because it invalidates all your test coverage or some at least. So when we think about learning then, where does it fit? Where does training or learning fit in this picture? It's quite difficult because you need to iterate quickly, you need to test quickly, you need to be able to change quickly. So that's something I think we are sometimes overlooking, and it would be cool if researchers actually look at this too. And yeah, the other bit is Total War campaign is a long endeavor, and it can take up to hundreds of hours to complete. It has a lot of different features and aspects of gameplay. So collecting, storing, or analyzing data is complicated. But it's fine. I mean, we are at the point at CA right now. We are handling the data really well and, storing, analyzing, and so on. But I think I mentioned this randomly in one of the slides. But one thing to keep in mind here is that's we only have player data once we release the game. Like I think Julian or Yorgos was saying, like if you have 50 or hundreds of levels, then you don't actually really need to generate more. It's sort of the similar thing here. We actually, release the game. Now we have player data. Of course, we can use it to improve the game better, but then it becomes a little bit of trade-off. What's the cost of doing that and how much it's gonna improve the game. So finding that sort of balance is actually not very trivial. Yeah, with all this in mind, when it comes to behavior and decision making, then maybe considering the AI to play the game as a whole is a little bit of a difficult challenge, and maybe we should start looking at smaller parts like we did in our traditional methods as well, maybe creating similar small systems to do prediction for diplomacy or some models for resource allocation and so on. Yeah, so far these are actually practical or production challenges. They're not really trivial, but we are making good progress in the R&D team on all of those things. The following questions are a little bit more trickier, and they're a little bit more about the crafting part of it, and it goes all the way to the first day or the start of my talk as well. Yeah, how do we define and model the challenge of fun, and how do we populate data around this? And most of the modern learning techniques, for example, they are amazing, they are great, but they are usually great when it comes to well-defined problems. And when we talk about things that are not easily quantified, they're a little bit looser definitions. Yeah, I'm not exactly sure how we can deal with such constraints with these approaches. I'm sure there's some approaches and interesting things that maybe I'm not aware of. And if you have any thoughts, ideas, papers, I'm more than happy to hear about them. And yeah, the overall game experience is the other bit here. How do you create different desired play styles? How do we create express variety for different factions? So that's also the other topic I want to tackle in the R&D team. And if you have any thoughts, that would be great as well. Right, so in the shorter term, we are looking at, seeking some answers to those questions. But we are also looking into more practical areas as well. For example, one of the things we are really interested in is AI-assisted tools, of course, for helping designers to improve their game, helping them to maybe create more dynamic stuff, helping them with balancing, and also helping them with player onboarding as well, because it is really difficult to explain a very complicated game to a new player. We are also looking into different optimizations, and of course testing is really, really important, and you have less constraints when it comes to testing, because if you're publishing something in the game, you need it to be working 100%, but if it is in the testing environment, 70% is still an improvement. So I guess that's a little bit better domain here. And yeah, player experience is also something that we are very interested in. So yeah, put a closing sentence here, right? At Creative Assembly and myself at R&D, we have strong interest in these topics. And yeah, if you have any thoughts, ideas, we are also open to collaboration. Please do reach out, or if you have any further questions or even want to challenge what I'm saying, you can just come and say, yeah, you said that, but that's not true. Here is the paper. That would also be very welcomed. So yeah, I'm more than happy to talk about with all those and learn from you. So thank you very much.